All right. All right. So we're going to look at chapter 1-9 on estimating roots. All right. So let's look at this. Let's say you have an exam and they're asking you to estimate the square root of 83 to the nearest integer. And many times when you take an exam, you have to do this without a calculator. I mean, it's easy to estimate it when you have a calculator and you can punch in the square root of 83. But suppose you do not have one and you still have to do this. Well, how do you do it when this is obviously not a perfect square and you are not a calculator? All right, it's real simple. What you're going to do is you're going to set up the problem like this, just like this. Write the problem that they're asking you about and give me an arrow before and an arrow after. And what I want is two perfect squares that you already know. One that comes before this number, one that comes after the number. For instance, the closest number before the square root of 83 would be the square root of 81. All right. It's very close to it. Most of the numbers, it'll be right next to it. You'll know what it is. Square root of 81. And then one after that, after the square root of 83, must be the square root of 100. All right. So what happens here is that we find out that the square root of 81, which you should know, is 9. And the square root of 100 obviously would be 10. And this square root of 83 is right in the middle of 9 and 10. But the question is it closer to 9 or is it closer to 10? That's what we need to know. And it's real simple to find out. You simply got to know if the number 83 is closer to 81 or if the number 83 is closer to 100. I hope you know that is closer to 81. And since 83 is closer to 81 than it is to 100, the answer is 9. That's what we're looking for. Now, when you actually plug in the square root of 83, you will get 9 point something, all right? But it'll be closer to 9 than it is to 10. All right, so let's look at this. Matter of fact, on that last one, I think the square root of 83 is 9.1. It's really close to 9. It really is. So let's look at this. Suppose I ask you, let's put it here. The square root of 20. All right. So you have to think of a number before the 20 and after the 20. So let's do this. Let me put my arrows in here and arrows there. What's the closest number to 20 that we know that comes before it? That's a perfect square. All right. And what's the closest number after it that we know? So we know the one before it would be a 16. And the one after it would be a 25. Once you know, let's say you didn't even know the 25 number. Let's say you figured out the 16, but you didn't figure out the 25. What do? Real simple. Matter of fact, I'm going to show you exactly what you should do in this case. The square root of 16 you should know is 4. What I normally do is the number that comes after 4 is 5. And I can work this way and say 5 times 5 is 25. It's going to work. It's going to work. So the question is the answer 4 or 5? Well, is the number 20 closer to 16 or is it closer to 25? It's only 4 numbers away from 16, but 5 numbers away from 25. So my answer in this case would be your 4. All right. So if we took our calculator and you got the square root of 20, you would get 4.47. That's almost halfway to 4.5. But still, it's 4.47, which is closer to 4. All right. Let's do one more example. Let's look at the cube root of 27. A little bit more challenging. All right. But you can still get it done. All right. What I would do in this case, because most people don't know their perfect cubes. A lot of students, they know their squares pretty good, but the cubes are, that's a different animal there. So what I would do on the side, I would go, well, what is 1 to the third power? 1. All right. What is 2 to the third power? That's 2 times 2 times 2. That got to be 8. What is 3 to the third power? That's 3 times 3 times 3. That'll be 27. All right. What is 4 to the third power? That's 4 times 4 times 4, which is 64. All right. So right here, let me not use this number because that's a perfect cube. That answers 3. So let's use something else. Let's say I had something like the cube root of 11. Okay. Nobody knows what that is. It's not a perfect cube at all. I would, let me put one more number here. The 5 to the third power. 5 times 5 times 5 is 125. So you should write down your perfect cubes. So the perfect cube, that means the cube root of 1 is 1. The cube root of 8 is 2. The cube root of 27 is 3. The cube root of 64 is 4. The cube root of 125 is 5, right? All right, so when I have the cube root of 11, I need to find where this falls in here. So that would fall right in between these two numbers. All right. So let's write those in. All right. 11 falls between 8 and 27. Get it? That's what I'm looking for. All right. So the cube root of 11, I need a perfect cube before it and a perfect cube after it. So if 11 is in between here, right, then the perfect cube before it is a cube root of 8, which is this one, and the cube root of 27, which is this one. All right. So I know that the cube root of 8 here is 2, and the cube root of 27 is 3, and the cube root of 11 is in between 8 and 27. So is the cube root of 11 close to the cube root of 8, or is the cube root of 11 close to the cube root of 27? Obviously, 11 is closer to 8 than it is to 27. Therefore, my answer is 2. All right. So hopefully that gives you an idea of how to estimate roots when they want you to find the nearest integer to it. Remember, you don't have to have all the cube roots memorized. Okay. But you can write them down on the side and work them out so you can have a few listed. And then you can plug in the numbers where they go. That will work out. All righty.